Alright, hi everyone, this is Mrs. Musoff, and we're going to be doing a couple extra domain examples today, just because I know sometimes domain can be a little tricky, so it's never a bad idea to kind of go through a few more examples together. Alright, so just a reminder, when it comes to the domain of a function, there are three restrictions that we've learned about so far in this class, and that is if there's a denominator, the denominator cannot equal 0. If there's an even root, whatever's underneath the even root has to be positive, or non-negative, I guess, so greater than or equal to 0. And then if there's an even root in the denominator, we combine those two, and it has to be strictly greater than 0. Okay, so let's try a couple problems using those concepts. All right, it says find the domain algebraically. Algebraically just means by hand, so not by graphing it. Okay, if you were ever unsure of the domain, a graph is a good way to double check yourself, but we want to try and find these by hand. All right, so for number 1, it says f of x equals 2x plus 1 divided by 6x minus 60. So I would take a look at my three possible domain restrictions and figure out which of those three apply here. So does this have a denominator? Yes, it does, right? 6x minus 60 is in the denominator. And so because of that, that means I'm going to use the denominator restriction, which is whatever's in the denominator cannot equal 0. So I'm going to say 6x minus 60 cannot equal 0. Sorry about that. Alright, so equations like this where we say cannot equal 0, we still solve it the same way as though it said equals 0. It's just that whatever answers we get, instead of saying x equals those answers, we say x cannot equal those answers. So this equation, I'm still going to solve it normally, add 60 to both sides. All right, 6x cannot equal 60, and then divide both sides by 6, and I get x cannot equal 10. And so that means my domain is all real numbers, that's that R symbol, but x cannot equal 10. And that's what I'd circle, or box. Okay, same kind of concept in number 2. All right, I'm going to look at the equation and figure out which of these three, if any, apply. Remember, if none of them apply, the domain's just all reals. So here I have g of x equals 3x divided by the square root of 3 minus x. So is this a denominator? Yes. Is this an even root? Yes, because it's a square root. Since it's both, we would actually say it's number 3. It's an even root in the denominator. So I'm just going to use this option for number 3. And that says whatever's underneath the even root, I'm going to set it greater than 0. Right, and I'm going to solve that inequality. Now, inequalities, remember, for the most part, are just like solving equations. The one spot you have to keep an eye out for is when you multiply or divide by a negative number, you have to flip the sign. So in this problem, for example, I'm going to subtract 3. So I'm left with negative x is greater than 0 minus 3. That's negative 3. And right here, if I wanted to solve for x, I'm going to have to divide by negative 1. Since I'm dividing by a negative number, that tells me that I need to flip my sign. So right now that sign is a greater than sign. Now I'm going to flip it. It's going to become a less than sign. All right, so this turns into x has to be less than, and now negative 3 divided by negative 1 is positive 3. So I would say my domain is all real numbers. X has to be less than 3. Okay. As an extra little note, I know sometimes in the past we've used interval notation instead of inequalities. If you wanted to describe x is less than 3 using interval notation, imagine drawing it on a number line. All right, if I had 3 right here, x is less than 3 would be an open circle, and then I'd shade to the left. So if I wanted to describe that as an interval, that would be from negative infinity all the way to 3. So it would be negative infinity comma 3. Negative infinity comma 3 with parentheses. Okay, so this is interval notation. This is interval notation versus if we were to just say all real numbers with x is less than 3, all real numbers with x can't equaling 10, right? All these different pieces. Okay. All right, one more example, the hardest one you'll see. is like number 3, f of x equals 2 divided by x squared minus 3x minus 10. So again, I'll look at my 3 options up here, denominator, even root in the denominator. And hopefully you can tell this one is just a denominator. It's just number 1. Because remember that x squared is not an even root, it's an even exponent. But that's totally different. Alright, so this would just be a denominator. So that means I would take what's underneath, x squared minus 3x minus 10, and set it not equal to 0. Well, this one's a little trickier to solve. It's not linear like number 1, right? It's a quadratic. So in order to solve this, even though it's can't equal, we treat it just like an equal sign. And if I want to solve this, I'm going to need to solve it by factoring. You could solve it using the quadratic formula, but it's way more complicated. It should always work out with factoring for our purposes. Alright, so in order to factor this, that means I need 2 numbers that multiply to x squared. That would be x and x. And remember, to find the other 2 numbers, we want what's going to add to this middle guy, negative 3, and what's going to multiply to the constant, the n number, negative 10. And so usually I'll make my list over here, alright, and say, okay, multiply to negative 10, that could be negative 1 times 10, negative 2 times 5. Negative 1 and 10 is not going to give me negative 3, but negative 2 and 5 almost could. I just need to switch the signs around. So I'm going to be using a positive 2 and a negative 5. And remember, factoring, the way you solve is you just set each factor, in this case not equal to 0. So x plus 2 cannot equal 0, and x minus 5 cannot equal 0. And then I would solve those. So I would end up with x cannot equal negative 2, and x cannot equal 5. So my domain would be all reals with these 2 exceptions. Okay. Alright, that's it. Those are just some extra examples. If you're doing your homework or you're doing the Delta Math assignment and you have questions, please feel free to write them down or email me. Even better is just to email me right away, and then we can answer those questions and figure out how to move on from there. Alright, thanks for watching.